Okay, we had talked about before that if you were going to go ahead and you were going to say x is greater than 3. Y'all remember that? And we've said, oh, it doesn't have the equal to part. So it would just get the parentheses because we're talking about everything greater than 3. And whenever if we put the equal sign underneath it, it didn't get a parentheses anymore. It got a bracket. Y'all remember that? This is kind of similar to that. This right here is my greater than sign, and it doesn't have an equal to underneath it. So that's why it has a dotted line through here. If it had the equal to sign, it would be filled in. It would be a solid line. And we'll go over that some more, but that's one of the things that they've got a dashed dotted line here. So it's because it doesn't have the equal to part. Another thing that you can do is to see if you are shading in the correct part is you can pick a test point. So this point right here is shaded in for me. -3, 2. So this point, -3, 2, should be a solution to my inequality, y is greater than 2x plus 3. And I can check that by plugging in for y, plug in 2. And then for x, plug in -3. And I would see, is this statement true? Is 2 greater than, well, 2 times -3 is -6, plus 3 is -3. And that is true. It should be true because it is an answer to this. It's in the shaded portion, okay, which is what this paragraph is talking about. Another thing I can do is I can check, I just want to show you that if I pick another point, maybe a point on this line, this point appears to be on this line, the point 0, 3. So if I go to the same y is greater than 2x plus 3, this is my x, this is my y, and plug in 3 is greater than 2. Instead of x, I'm putting in 0. So I replace my x with 0, I replace my y with 3. So 3 is greater than, that's going to cancel out 3. That's false because there's no equal to part here. So whatever's on that dash line is not a solution. So everybody okay with that? If the line was filled in, it was a solid line, it would be a solution. Okay. So that's kind of what these problems are trying to get you to figure out, which points are going to be solutions and which ones are not. So when we go to this first problem, it says to graph the linear inequality in the plane y is greater than 1/2 x minus 3. So this line is actually drawn for you. If you were to work this problem by hand, you would need to go to your calculator and you would need to type in 1/2 x minus 3, and you're going to have to find at least 2 points that will work on that line. Okay, so I'm just going to, I know you know how to do that in the calculator, so I'm not going to keep going back and forth. Does anybody need to see that? So if I plug in 0, I would get -3. If I plug in 2, I'm going to get -2. And they found different points, I think, but 0, -3 is right here. And 2, -2 is right here. So those would work as well, right? You know how to, does anybody, you understand what I'm saying? You go to the calculator, find 2 points. Then you need to decide, is this a solid line or is it going to get a dotted line? I'm going to get a dotted line because it doesn't have the line underneath this greater than, it just has greater than, okay? The next thing you need to do is you've got to decide which part to color in. So there's several ways to do this. This book or this, the curriculum that we use asks you to pick a test point. I always pick 0, 0 unless the only time you can't pick 0, 0 is if this line went through 0, 0. Okay, but what I do is I try that test point and I say, okay, is 0 greater than 1/2 times 0 minus 3? Okay, so I go, well, there's nothing to do on this side. Half of 0 is 0, and then we've got -3. Is 0 greater than -3?
Yes.
So we would say yes, or that is true, and 0, 0 is right here. So that must mean that the points that are above the line are the ones that work. Well, if I had have gotten false there, if that wasn't true, what would I need to do? Don't color in the top because that's where 0, 0 is. I would color in the bottom. Okay. Okay, so for working this one, the first thing we're going to want to do is go to our calculator, type this in to our y equals, and find a couple of points. So if I plug in 0, I would get 2. If I plug in -2, I would get 0. I just picked 2 in my brain, but so we wouldn't have to keep going back and forth. So 0, 2 is right here. -2, 0 is not on there because I did something wrong. So a -2 is +2. So this should be 4. So -2 is supposed to be 4, which is up here. Okay. Is this one going to be solid or dotted? Because it doesn't have the equal to part, it's going to be dotted. You're correct. 0, 0 can still be my test point because it's not on that line. So I would come over here and say, well, is 0? I'm plugging in 0 for X and Y. So is 0 greater than 2? That is false. 0 is not greater than 2. So that means that I don't color in the bottom where 0, 0 is. I would need to color in the other portion. Does that make sense? Right here, I lose people because they're like, what? So we found out that that point 0, 0 did not work. So I wouldn't want to color the side that 0, 0 is in because it doesn't work. I would want to color in the other side. Okay. Graph this linear inequality in the plane. Y is greater than or equal to 1/3 X. So I would need to find a couple of points. If I plug in a 3, I'm going to get 1. And if I plug in a 6, I'm going to get 2. I know that. So 3, 1 is on this line. 6, 2 is on this line. Solid or dotted?
Solid.
Because it does have the equal to part. Okay, can 0, 0 be a test point here? No. So don't, because it's on the line. So that's not going to help me decide what to color in if it's on the line. I need to pick any other point that's not on the line. Okay, so you just go and pick one. Don't make it super difficult to yourself. I'm doing this in my head, so I know I'm going to pick something with a 3 because the denominator's a 3. But you can go to your calculator and look at, actually, you're not going to be able to do that. You can definitely use your calculator to solve the problem for you, though. So I'm going to say plug in 3, 0. So when X is 3, Y is 0, I'm going to plug that in for my test. I'm going to say, well, that means 0 is greater than or equal to 1/3 times 3. These are going to cancel out. So 0 is greater than or equal to 1. No, that's false. So that was my test point right here. That means that I don't color in my test point. I'm going to color in the other side that doesn't have my test point. Is everybody okay with that? Okay. So here we go. We've got some that we're going to kind of start from scratch. So I'm going to encourage you guys to now go to, since we don't have a line, let's go to the graphing calculator on this first one And let's find some points. So we only need 2 points. So our equation is 2/3 x plus 1. So I'm going to we would go to y equals alpha y equals enter 2/3 x plus 1. I'm going to hit second graph so I can find some points. I don't want to pick those ones that are fractions because that's going to be confusing for me to plot points. So 0, 1 would be a good one. 3, 3 is a good one. So we said 0, 1 and 3, 3. So 0, 1 right here, 3, 3 right here. Going to be solid or dashed or dotted. It's going to be solid because it has the equal to part. So when I connect the dots, should be filled in. Okay, now I need to pick a test point. Can I use 0, 0? Yes. So I'm going to go y is less than or equal to 2/3 times x plus 1, but I'm going to plug in zeros for my y's and my x's. Well, that's going to give me 0 is less than or equal to 1. That's true, correct? 0 is less than or equal to 1. So this point right here, 0, 0, is one of the answers because 0 is less than or equal to 1. So I would color in the point where the test point is. Okay. How are you guys gonna, I'm gonna let you kind of lead what you would do here. How are you going to find some points that are on this next line? Could use the intercept thing here if you wanted to. I think most of you are probably gonna go ahead and get this to say y equals. That I'm gonna just try to stay consistent because that's what we've been doing. So we would subtract -3, or we would subtract 3x from both sides. So 2 minus 3x. How do we get rid of that negative in front of the y? We could either multiply by -1 or we could divide by -1. It doesn't matter. But when you are solving an inequality, we've already done this in this class. If you're solving an inequality and you multiply or divide by a negative number, what happens to this sign? Goes the opposite way. Okay, only when you're solving, only when you multiply or divide by a negative number. So y is less than -2 plus 3x. Now we should be able to go to our calculator and type that in and come up with a couple of points. I'm going to let you guys do that. What are a couple of points that we can use for that? We're going to say -2 plus 3x. Somebody has got a point. Which point's going to work on this one? I hear 0, -1. So if we plugged in 0 right here, that's going to give us -2, right? You okay with that?
Yeah.
0, -2. Okay. What's another one that's going to work? You're a -2, 4. So is that, did I hear that correctly? -2, 4. Okay. 3 times -2 is going to be -6. So I think that -2 is going to be -8. Did you do -2 plus 3x?
It's a +2 and a +4.
Okay, I'm hearing +2 and +4. So if we plug in 2, we get 6 minus, yes, 2, 4 work, right? So those 2 points will work. So 0, -2, and 2, 4. You just typed it in wrong, didn't you? That's okay. And so this is going to get a dotted line because it does not have the equal to part. And you guys are just going to have to excuse me right now because it's hard for me to draw on this little. Try to not make it too crooked. Okay, can I use 0, 0 as my test point? Yes, because 0, 0 is not on that dashed line, so we're good to use 0, 0. So 3, and it doesn't matter which equation we plug it into. I'm just going back to the original one. So if I plug in 0 minus 0, so that 0 is greater than 2. No, right? 0 is not greater than 2. That's false. So that means I wouldn't color in that side of the line. I would want to color in the other side. Okay. It would be really easy on this one to find intercepts for this one, because if you let x equal 0, I'm just giving you another option. So I'm going to do the intercepts. If we let x equal 0 here, then we cross out this, because that would be gone if we let x equal 0. What is 6 divided by 3? 2. Okay, and you could still, like, there's nothing wrong with plugging this in the graphing calculator. If I let y equal 0, then this would be gone because 3 times 0 is 0. So that means that x would have to be 6 divided by 2, which is 3. Okay, so that's how I solved that one, because it was way easier than me having to solve it for y and do all that other stuff. If you still want to solve that for y, go. I mean, we've got lots of examples of that. That's fine to do that. So 0, 2, and 3, 0. Is this going to be a dashed or solid? I'm keep trying to say filled in and not solid. It's going to definitely be solid because it has the equal to part. We would want to connect those dots. We can use 0, 0 for a test point because 0, 0 is not on our line. So we could do 2x plus 3y is less than or equal to 6. So 2 times 0 plus 3 times 0 is less than or equal to 6. Well, 0 is less than or equal to 6. Yes. So that means that wherever 0, 0 is, that's the part of the line I want to color in. Okay. Are you guys still doing okay? Okay. These two are super easy because hopefully in support you got, if I wanted to graph x is equal to 2, then I would go to x is equal to 2, which is right here, and I need to draw a line through it. Okay. So it does have, before I draw the line, I need to decide, is it solid or dotted? And it is solid because it has the equal to part. So it's solid. And I would draw a line right through there. Okay, you can still use a test point on this if you want to, but you probably can use some common sense and say, well, I need all x's that are greater or equal to 2, which would be x is what? What's another x that's greater than or equal to 2? 3, 4, 5. So that means that this side would be shaded in. On this one, we've got y is less than -2. So we would go to where y is equal to -2. I'm just going to kind of put a dot right there. I want to draw a line through that. Since there's no equal to part, this one is going to be dotted. When I draw a line through there, it's gonna be more like kind of that dashed line or dotted line through there. Okay, and we want all the y's that are less than that, so that would be the bottom of our graph. Things that are below y's that -3, -4. So that was pretty good with that. Okay. There's not a whole lot of these that you have to work, but we do need to go over this problem. So I'm gonna kind of divide, so it has to meet both of these things. There's two equations here. So I'm gonna kind of divide this into, talk about separate. So one of them is x plus y is greater than or equal to 3, and the other is x minus y is greater than 1. Okay. So we're supposed to graph this system of inequalities. I can solve this for a y if I want to. It would be really, really, really easy to come up with the intercepts on this one. If x is 0 here, so if x goes away, then y is 3. If y goes away, so if y is 0, then x is 3. Do y'all see that? Okay, we could solve it for y and find points in our graphing calculator. There's nothing wrong with that. So 0, 3, and 3, 0. So we're kind of doing the same thing we were doing. This does get a filled in solid line because it does have the equal to part. Okay. And I need to pick a test point. I'm going to pick 0, 0 because it's not on the line. So is x plus y is greater than or equal to 3. So 0 plus 0 is greater than or equal to 3. That is false. So my test point was right here. So I don't want to color that in. Everybody okay with this so far? Before you start coloring, and you may have already started coloring, sometimes when it's a system of equations, it's easier to see what's going on if you just draw these straight lines out like this. If you already colored it in, you'll be okay, but okay. So I'm gonna, and I know that you guys don't have the luxury of picking a different color, but I'm going to because I can, and it'll help you understand better. So I'm gonna do the intercepts are kind of easy on this one too. So if x is 0 here, then that would end up being negative y is greater than 1. So we would divide by -1. That would make us switch our sign, but that doesn't really matter right here. So y is -1. If y is 0, then this whole thing's going to go away and x is just 1. Okay, you can solve for y and plug it in the calculator to get your points. That's fine if you want to do that. So 0, -1 is going to be down here. 1, 0 is going to be right here. I am going to make a dashed or dotted line on this one because it does not have the equal to part. Okay. I can use 0, 0 as my test point again because it's not on the line. So x minus y is greater than 1. 0 minus 0 is greater than 1. No, right? That's false. So I don't want to color in the side that has 0, 0 on it. I want to color in the other side, and I'm going to use these straight lines to do this. Okay, so the solutions to this problem are where the blue, that's why I said to draw the lines instead, are right here in this little triangle, where the blue and the red both are. Does that make sense? Okay, so that's where if we pick a point in here, that should work for both of them. If we pick any other point, it might work for one of them, but not both of them. It has to be where the blue and the red is. It's going to work for both of them. Okay.